Hello and welcome to yet again another video on exponents. Now we have done the simplest of examples and stepped up the examples in the videos that we've been doing, and even ended on the ones that we had to factorize in the previous video. Now the following ones are the toughies, as I would call them. They require a little bit more thinking and a bit of many other skills like factorizing or dealing with fractions. So let's look at these. So the first one here is x to the power of minus 1. So a common thing that people want to do is just cancel over a plus and minus. But as I said in the previous video, you cannot cancel over plus and minus. Your trick is to factorize. Now you can see, how would you factorize something like this? Well, the numerator you can't factorize. There's nothing much you can do about that. So I'm just going to write the numerator as it is. There's no common factor. There's no way to factorize it. But the denominator, on the other hand, it's a perfect square minus a perfect square. What is that the form of? It is the form of difference of two squares. So what you're going to do is the square root added to the square root of the next term, and then the square root, subtracted from the square root of the next term. That is your typical kind of difference of two squares factorizing, okay? It applies to exponents even if they're negative too. Now what do we have is, now we have that there's a x plus 1 plus that in the numerator, and a x to the power of minus 1 plus y to the power of 1 in the denominator, and they cancel because now the operation between them is multiplication. So what we're left with is this. We can still simplify it further. So this here is equal to 1 over x minus 1 over y. Now how do we deal with fractions? Well, we find the lowest common denominator, which in this case will be x, y. So this one was over x, so we're going to multiply that 1 by y, and this one was over y, so we're going to multiply that by x. And when we taking one and dividing by a fraction, what does it do? It actually inverts the fraction. You can go and check that is your answer. The next one, we look at this one here. Again, it's got that addition, so any tendency you have to want to cancel out, you can't. We have to factorize. So we have a perfect square minus a perfect square. So what are we going to do? Difference of two squares okay, and then what we have is that cancels out with that again, leaving us with 1 to the power of minus 1, and then we can change that to a positive exponent, so it's 1 over m. We can make this a single term, so it's m, well, expression, so it's m. This is over nothing, so we're going to multiply it by m over 1. Okay. The next one, we've got this over here. Again, we have addition and in this over here, so we cannot cancel. Here we can factorize, but is there a factor over here? No, it's not the difference of two squares in the previous one. There's addition here. There's no addition of two or sum of two squares. It doesn't exist. So we have to look for another way. Let's use the exponent laws to simplify that. So this is a over b over 1 over a plus 1 over b. That we're allowed to do. And we're going to find the lowest common denominator over there. So it's a over b. Okay, the lowest common denominator between a and b is ab. That is already over a, so we're going to multiply it by b. This one is already over b, so we're going to multiply it by a. So then I'm going to write, I don't like a fraction over a fraction, so I'm going to write a plus b divided by b plus a over ab. And how we deal with fractions is we tip in times. Okay. And a plus b is the same as b plus a. They're the same thing, so they cancel out, leaving you with just ab. Okay, last question. That was the last question. So those were a few interesting ones where you had to manipulate a little bit to get to the answer. I hope you enjoyed this video. I hope you watched the full set on exponents. I have no doubt after watching and doing the questions that you should have a good handle of exponents. Please subscribe, watch, and like. Comment below on what you'd like to see in the videos. And thank you so much for watching. Bye.